In this video lesson, we are going to review some basic divisibility rules that you may have learned in middle school or junior high and will be helpful to you when you are trying to factor. This is important for us as Math 10 students because factoring is a very major skill in this unit, and divisibility rules will help us to quickly recognize different factors. Let's start by making sure that we understand what it is when we are going to factor. Factoring means that we're going to show what numbers multiply together to give you the value you started with. So we notice here that factoring is very strongly tied to the idea of multiplying, which means that factoring is also closely related to dividing. Factoring is like dividing because we can think of factoring as trying to undo multiplying. Factoring is different from dividing because dividing will actually change the value and factoring does not change the value. Let's begin for our rule for checking for divisibility by 2. That's pretty simple. If the number is even, it's divisible by 2. 144 is even. We can think of this as two groups of 72. 521, not even, no factor of 2. 2,816 is even. We can think of this as 2 multiplied by 1,408. If you want to know if a number is divisible by 3, add up all the digits, and if they add up to a number which is a multiple of 3, your original is divisible by 3. So for 27, 2 added to 7 is equal to 9. 9 is a multiple of 3. So 27 can be thought of as 3 groups of 9. 217, 2 plus 1 is 3, plus 7 is 10. 217 is not a multiple of 3 because 10 is not a multiple of 3. For 480, 4 adding 8 is 12, add 0 is still 12. 12 is a multiple of 3. 480 is 3 multiplied by 160. And if you weren't sure about that 160, you could take 480 divided by 3 on your calculator. A number will be divisible by 4 if the last two digits are divisible by 4. So 104, those last two digits, 0, 4, basically a 4, that's definitely divisible by 4. 104 is 4 multiplied by 21. 216. Looking at the last two digits, we have 16. That's a multiple of 4. 216 is 4 multiplied by 54. For 5,094, we might not be sure if 94 can be divided by 4. So let's think of it as 80. That's definitely a multiple of 4. Plus 14. 14 is not a multiple of 4. Which means 94 isn't, which means 5,094 isn't. A number is divisible by 5 if the last digit is either a 0 or a 5. So 11 is not, but 625 is. That's 5 groups of 25. And 11,230 is. Definitely going to use our calculators to help us here. This is 5 groups of 2,246. A number is divisible by 6 if it is divisible by 2, so it's even, and it's divisible by 3. Well, 26 is even, so let's add up those digits. 2 added to 6 is 8. 8 is not a multiple of 3, so 26 is not a multiple of 3, and it can't be a multiple of 6 either. For 2,166, it's even, so let's test for the 3 factor. 2 adding 1 is 3, add 6 is 9, add 6 is 15. 15 is a multiple of 3. This is an even multiple of 3. Using our calculators to help us out, 2,166 is 6 groups of 361. To find out if a number is divisible by 7, it takes just a little bit more work. We're going to break the last digit of the number off and double it. So for 14, we will think of 1 and 4 groups of 2 or 8. We're going to subtract this doubled from the leftover part. 1 subtracting 8 is -7. If your result is divisible by 7, the original number is 2. Since -7 divides very nicely by 7, 14 is a multiple of 7 as well, and we already knew that. Let's try the second piece. The front part will be 14. Our last digit is a 1. We'll double that to get 2. 14 subtracting 2 is 12. That's not a multiple of 7. 7 is not going to divide nicely into 141, or in other words, 7 is not a factor. For 343, we will think of 34 and 3 groups of 2. 34 subtracting 6 will be 28. 28 is divisible by 7, and so 343 is as well. 7 is a factor of 343. It is 7 multiplied by 49. A number is divisible by 8 if the last 3 digits are divisible by 8. This asks us to recognize some pretty large multiples of 8. So practically, as Math 10 students focused on prime factorization, it's going to be a lot more helpful to check for divisibility by 2 or 4. A number is divisible by 9 if the digits themselves add up to a multiple of 9. With 63, 6 adding 3 is equal to 9, so 9 is a factor of 63. 63 is 9 groups of 7. 117, 1 adding 1 is 2, adding 7 is 9. 117 will be 9 multiplied by 13. 4,680. 4 adding 6 is 10. Add 8 for 18. Adding 0 still leaves us at 18. 18 is a multiple of 9. 4,680 is 9 groups of 520. A number is divisible by 10 if the last digit is 0. So 1,740 is 10 groups of 174, and 5,000 is 10 groups of 500. This is probably our easiest divisibility rule. To check for factors larger than 10, it's often easiest to test with your calculator, and so for factorizations, it's very helpful to look for factors between 1 and 10 first. If we begin factoring 1,188, it doesn't end in a 0, so there's no factor of 10. Let's check for a factor of 9. 1 adding 1, adding 8, adding 8. All of these digits add up to 18. So 1,188 has a factor of 9. Let's use our calculator to check this out. Testing on our calculator, we see that our 1,188 can be considered as 9 groups of 132. I wonder if that 132 can be broken down anymore. Well, I notice that it's even, and if we consider those digits, 1 adding 3 adding 2 is 6. That's a multiple of 3. It's even and a multiple of 3. 132 must have a factor of 6. So we're going to think of 9 groups of 6 multiplied by something else. Let's use our calculator to figure out what that is. Since 132 divided by 6 is 22, we can now think of this original 1,188 as 9 multiplied by 6 multiplied by 22, and we could break that 22 down a little bit more so that this is 9 multiplied by 6 multiplied by 2 groups of 11. So the only real question is, how do you know how much factoring to do? That's why in Math 10 we talk about prime factorization, which has its own video lesson.